Alright, so now that we have found all the derivatives of the loss with respect to the parameters, now we can actually go ahead and use this formula to find the optimal values for the parameters. So I'm just going to define a function. We're going to call it update params. It's going to take in all of the old values for the parameters w1, w2, b1, and b2, and we also need the derivatives of the loss with respect to the parameters. I'm just going to call them w1, lw1, lw2, we have lb2, and we have lb1, and we also need the learning rate. Alright, so now to update the values for the parameters, the new value is going to be the old value minus the learning rate times the derivative of the loss with respect to that parameter. So that's LW1. I'm just going to copy this and paste. So the same thing for W2. It's going to be learning rate times LW2. And now we can just paste again. This time it's going to be for B1. It's lowercase b. So now it's LB1, and now just copy this and then paste. Now for B2, new values equals to old value minus learning rate times the derivative, which is LB2. Now we can just return all of these values. So W1, W2, B1, and B2. Alright, so now we can define a function for finding the accuracy of the model. However, before we do that, there's a few things we need to fix. So it turns out I made a few mistakes in the previous parts. So instead of just hard coding these values out for the number of features and for the number of samples, we can just define two variables. I'm going to call them num samples. And that is going to be the data.shape of 0, and num features is going to be equals to data.shape of 1. And we're going to replace this with the number of features and this as well. And it turns out it wasn't actually 783, this is 785. So it could cause an error if you try to run this later on. And this as well, we can change this to the number of samples. Alright, so just run this. Oh, we made a small mistake. This is supposed to be closed. Something else went wrong. Oh, NP is not defined because we need to rerun this. We can do that later. All right, the other stuff which we need to change is going to be, we need to multiply each of these by 0.01 because that's going to make the training process much faster. So just copy that, paste, paste, and paste. We're going to multiply each of the values by 0.01, and we can run it later. When we define all the modules, we can just run all the cells at once. And the other stuff. Okay, so we need to change this to np dot maximum because it's not one value that we're dealing with. This is going to apply the value function to every single element in the array that we pass it to. And we can also, just to be on the safe side, add brackets here because we need to compute. We need to divide 1 by all of this. And over here, it's actually supposed to be lowercase w. And we need to return LW2 as well. We can now define a function to find the accuracy. So first, we're going to define a function for the predictions. It's going to take in an array as input, and it's going to return np.argmax of ARR along the axis 0. So don't worry if this does not make sense. I'm just going to explain this in a bit. So we need another function which is going to be get accuracy, and it's going to take in the y hat, which are our predictions, and y, which are the actual values. So we're going to, what just happened? We're going to return np.sum of y hat equals to y divided by y dot size. Alright, so let me just explain what we're doing here. So basically we have we're gonna have a 2, which is going to be an array which stores all of our predicted values. So this is the output that we got from the final layer, the output layer, after we applied the softmax function. So it's gonna store the predictions for every single sample. So this right here, these values right here are probabilities. So this is basically represents how confident is our model in each one of these classes. So we have 10 different classes or 10 different outputs here, so 0 up till 9. So what that means is our model thinks that there's a 10% chance that the given image is a 0, and there's 20% chance that this image is 1, and so on. So we need to find which one has the highest probability, which is 0.9 for every single sample. So for this one as well. So for this sample, the second sample, the model thinks there's a 90% chance that the given image is the digit 6. So what we're doing here, we're applying the argmax function on it. So basically it's gonna give us back the index. When we apply the argmax function on this array right here, it's gonna give us back an array like this. Basically it's gonna pick the value. We said that the axis is supposed to be 0, so this actually refers to the axis of 0. It just means it's going to look at the each column vertically, and it's going to give the highest value in the column, which is 0.9. It's actually going to give us back the index of the highest value, which happens to be 3. So it's going to store a 3 for the first sample, and for the second sample as well, it's going to find the probability which is the highest vertically for this sample, and it's going to give us back the index, which is 6, and we're going to store 6 over here, and it's going to do the same thing for every single sample. So basically when we get the index, this is basically what our model thinks. So for the first sample, our model thinks that the given image is the digit 3. So that's basically what we're storing here, and these are our predictions. And then after we have all of our predictions, we can then get the accuracy, and we do that by summing up. Basically we're comparing the predictions against the actual values, and we're seeing how many of these values actually match. So when the prediction is exactly equals to the actual value, that is when there's a match, and we're summing up all of these matches and dividing them by the size. So that's going to give us back the accuracy. Alright, so after we define all the modules, we can go ahead and define our final function that we're going to use, which is going to be the gradient descent. And it's going to take in a few inputs, which is going to be x, y, and we also need to specify how many iterations this is going to run, and we also need the number of samples. Alright, so the first thing we need to do, we need to initialize our parameters. So we're going to use this function right here. And this is going to give us back W1, B1, W2, and B2. And we can just confirm that is the correct order in it, which is just going to return back the values. So let's just confirm that. Alright, it is this exact order. Then after we have done the after we've initialized our parameters, we can then go ahead and define a loop. So for I in range iterations, so however many iterations we specified. It's going to run that many number of times, and it's going to repeatedly do a forward pass, backward pass. It's going to update parameters repeatedly until we have a loss which is minimum, or we have a very high accuracy. So we can go scroll up here and just copy this, and then we can just copy the return values as well. Alright, so let's just see, we have all of these. We have X, alright. We have W1, B1, W2, and B2 specified, alright. So after we've done a forward pass, we can do a backward pass to find all of the derivatives. Just copy this function call, and we also need the return values. You can just copy these variable names. And let's just double check to see if we have all of these. We have X, we have Y, we have A1, A2, W1, W2, but we have Z1, but it's capital Z. It's not lowercase, so we can just change that. And we have M. We have number of samples, so we can just replace that. So after we've done a backward pass, we can update our parameters. So we can just copy this function call. Just copy the function call, and then paste that in the next line. And then just copy the return values. Then we can just paste that here. And then let's just confirm to see if we have all of these. We have W1, W2, B2. We have all of these, and then the learning rate is something we need to specify, which is going to be 0.1. Alright, so after we have all of this, we have then forward pass, backward pass, update parameters. Then we can do one thing. We can check every 10th iteration. So if I mod 10 equals to 0, meaning if we're at the 10th iteration, we can just print out the accuracy to see how well we're performing. So before getting the accuracy, we need to get the predictions. If you remember, we defined a function for which used argmax, which was called predictions. So basically it takes in A2, which is the predictions that we get. Oh, my bad. Basically this takes the array A2 as input, which are the outputs that we get from the final layer, and it gives us back the output in a more presentable format. So it tells us basically for the first sample, our model thinks that the given image was a number 3, and the next was 6, and so on. It basically tells us what number does our model think the image represents. So we can just pass in A2 as input here for predictions, and then we can just type in a string here, and we're going to call the function for get accuracy. And it's going to, first of all, we need to pass in the predictions, which is this variable right here, and y, which is going to be our y train, the actual values from here. And I think we have an extra double quote here. We can just supposed to be single. Yeah, I think that's it. And then we can just you can just call this function here. I already called it once, beforehand. So you can just type in the inputs, which are the first input was the x train. So the inputs, then we have the actual values, which is the y train. So this is the data that we set aside for training, and then we need to specify how many iterations. So let's just do 500 first, and this is the number of samples which we defined up here. All right, so we can just do a quick test. Just click on this. Okay, actually just run all, because we didn't run the previous cells. Oh, there's a error. It says predictions referenced before assignment. So I think we can't have the same name. So let me just call it P instead. I'm just gonna call this P. All right, then run this cell. Alright, so after running 500 iterations, you can see we're left with an accuracy of 88%. Now to improve this, you could tweak a lot of different things. You could add more layers to the neural network. You could use more data to train the network. You could even tweak the learning rate. There's a lot of different things you can change to get a better accuracy. So guys, that's it for this video. I hope you enjoyed watching it.